All right, so we are going to test the conductivity of the different materials in the electrical conductivity lab. So you'll want to have that open while we're testing these. So we're going to start with the copper wire, and make sure you have your predictions filled out before we go ahead and test. Also, let me just tell you a little bit about the conductor. So there's a light bulb up here, and then we've got two metal prongs. These are also called electrodes. You have to make sure that when you're testing the material that both of the electrodes are touching the material to get a good, nice closed circuit. If the circuit is closed, then that means that there's a pathway for the electrons to flow out and then back into the circuit. And so that will cause the light to light up. So if we're testing a conductor, then we will see the light up because we have a closed circuit. If we are testing an insulator, then the electrons are not going to be able to flow freely, and the light bulb will not light up. Okay, so we're going to go ahead and test our different materials. So first up is the copper wire. So here's a little piece of copper wire. Make sure you are touching both electrodes and the light is blinking. So copper wire is a yes. The next is pencil lead. And a common misconception with pencil lead is that it is the element lead, and it's actually not. It's graphite, which is made of carbon. So we're going to test that. So make sure you have your prediction, and we're going to touch both electrodes, and graphite or pencil lead does light up. It does conduct. So that is a yes. So even though it's not a metal, it is still a conductor of electricity. It can still conduct. It may not be a great conductor, but it conducts enough for the light bulb to light up. Okay. Our next item is the paper clip. Again, make sure you have your prediction filled out, and the paper clip does light up. So there you go. It's kind of hard to make sure. There we go. Okay, paper clip is good. Aluminum foil, make sure you've got your prediction for aluminum foil. There you go, it lights up, it does conduct. Salt, I've got a little container of salt here, and salt does not light up. Salt does not a conductor. Okay, a quarter or a dime, looks like we have a dime. Make sure you've got your prediction. The dime does light up, so the dime is a good conductor. What's next? The penny. So again, make sure you've got your prediction. The penny is lighting up. The penny is a conductor. Penny is a yes. Sand. Got a little container of sand here. Sand is not lighting up, so sand is not a conductor. Not a conductor. Okay. The nail. Here's the nail. There we go. Oop. Make sure we got a good connection there. Sometimes you have to press firmly on the prongs on the electrodes. That is a conductor. The nail is a yes. The toy nickel. So we've got a toy nickel. So it's made of plastic. So let's see. And that one is no. Does not light up. Not a conductor. Ceramic tile. Okay. Ceramic tile is not a conductor. Does not light up. Binder clip, just the colored part here, and that's not a conductor. So this confused some people. So this is just a painted part of metal, but the paint, because the paint is not a conductor, it's blocking the metal from touching the conductors. So if I tested this part, you can see that it lights up, but the painted part does not light up, okay, because the paint is not a conductor. Oops, did I skip one? I did. I skipped the plastic beaker. So here's the plastic beaker, and it is not lighting up. Okay, so not a conductor. Let's make sure I got the rest of them up to this point. Okay, and I'm going to go ahead and test the solutions now since they're right here, and then we'll go out and test the lockers. Okay, so salt water. Okay, oh, you can't see that. Okay, yep, salt water conducts. Let me wipe the electrodes off. Tap water. So you can see it, it's very weak, but it is still lighting up. Bring it closer for you. You can see that. It does light up. Even if it lights just a little bit, it still counts. We'll talk about that in class later. Well, you know what? You may not be in class because you're absent. So I'll tell you right now. So what the deal is, why the tap water lights up is because tap water is, it has ions in it. It's not just pure water. If you had distilled water, then you would have water that, or deionized water, water that doesn't have any ions floating in it. And if you have free floating ions, then those are going to be able to flow and conduct electricity. So if you see a drink that says it has a lot of electrolytes, that means it has a lot of ions in it. You can see the salt water is very bright. Compare that to the dimness of the tap water, right? So the salt water, because it has salt in it, NaCl, it has a positive sodium ion and a negative chloride ion in the salt water. So it has a lot more ions than the tap water. So the salt water is a lot brighter. Then you have vinegar. Again, it is lighting up. So there are ions in the vinegar, and wipe that off. And then the lemon juice. Okay, the lemon juice is lighting up as well. So all four of our solutions conduct electricity. They have ions floating in them. So they are all conductors. And let's go ahead out and test the locker. Okay, locker. So this part, nothing. The lock, again, nothing, but some people tested this part of the lock, and obviously that part is going to light up because it's metal. This part doesn't light up because it's painted, just like the binder clip didn't light up. And then this part of the lock is not going to light up because it's plastic. But this part of the locker lights up because it's metal. So the front and the lock, depending on what part, let's do the middle part here. The middle part lights up too, because that is metal as well. So the front is definitely a no, but the lock, it depends on what part of the lock we're talking about. If you're talking about the metal part in the middle, then that's a yes. If we're talking about this part that you move around that's plastic, that is a no.